Done. Noted, everyone?
Yes, sir. Distribution of electrons.
Yes, sir. Finished.
Okay, so first of all, if I'm saying here that this was if I'm talking about the neutron, and electrons have three subatomic particles: electron, proton, and neutron. Okay, electron was discovered by J.J. Thomson by cathode ray experiment, and that neutron was discovered by Chadwick. And similarly, if I'm talking about the proton, proton was discovered by Goldstein. Okay, and we're going to study three types of model here. One is atomic model, is Rutherford model. First is Thomson atomic model. Second one is Rutherford, and the third one is Bohr model. Okay. Now make this chart fast.
Okay. Above.
Sudden.
Okay, so let's move. What we're going to discover. So John Dalton did an experiment that was done in order to for the discovery of electrons, and how he discovered the electrons. Let me explain you. So electron was actually discovered by J.J. Thomson, okay, by a cathode ray experiment. Let me show you that how he discovered this one. So he took um, this type of structure of a cathode ray in a cathode ray experiment, okay, and he made this type of structures, and he named it as cathode ray experiment. Okay, this glass tube is going to have very low pressure. This glass tube is going to have very low pressure. Okay, and almost negligible amount of air is there, which is having 0.04 mercury mmHg. That is very low pressure. Okay, and moreover, very high voltage is being passed here. So when he find that when we are having such type of conditions, when the air is very low, the pressure is very low and high voltage is passed, then air start conducting. Air become conductor. Okay, and he also noticed this one, that when we pass electric current to it, okay, high voltage electric current, then there are some beams that are started passing through these. Okay, and he named it as cathode ray. Cathode ray experiment. Let me show you that how it is, so that you can understand in much better way. Cathode ray experiment. Okay, this was the cathode ray experiment.
Cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal of the battery. It was observed that, at normal pressure, the gas did not allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This
So what is this? What is the saying? He's simply saying that when we are having this type of electrodes, okay, then these rays start producing, okay, and from negative terminal to positive terminal, they start producing from negative terminal to positive terminal, okay, and this is negative here. It is a negative terminal, and they start moving from negative to positive terminal, okay, got it. And moreover, these rays are deflected when we have an external magnetic field, indicating that these are the charged particle. Okay, these are the beams of charged particle. Let me show you, explain you. Just first you watch this video, then I'm going to explain you whole thing.
shows that cathode rays travel in straight line. 2. When a wheel was placed In the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive.
This is the important. When we produce an electric field, then these rays start producing. They are deflected to some. Okay, these are deflected to positive terminals. Means these are indicating that these are negatively charged particles. Means if they are attracted towards the positive, so only the negative charged particle will be attracted toward that positive. If it is negative, if it is positively charged particle rays, then it will be deflected towards negative. And if it is neutral, no charge, then it will not be deflected with any positive or negative terminals, okay, or any electric field. They will not be affected. So only the charged particle beams are affected. For example, if you take a normal laser lights are not charged particle beams, okay. So it will not be deflected. It will not be deflected. It will move in a straight line. Okay, I'm going to show you
Plate.
this first.
This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
So let me show you that how actually this experiment works. Okay, let me show you first of all, when Thomson was doing this experiment, he found that these rays are charged particle beams. Okay, and how he concluded that these are charged particle beams? Because whenever a charged particle moves, like, then it behaves like a magnet. Let me show you that Oersted experiment. Okay, let me show you the Oersted experiment, and then you will observe that how does Oersted experiment. Oersted experiment was the experiment in which it shows that when we are having a charged particle, okay, let you see that this you can
So I have here a large magnet, South Pole, North Pole. So the field is pointing
okay,
up.
this is the South Pole and this is the large magnet. Okay, this is the magnet which is having North Pole here and South Pole here, and this is a normal wire in which electricity is not produced. Electricity is not there. Okay, but as you know that when we pass electric current to it, then this copper rod will start behaving like a magnet, and magnet attract the another magnet or repel the other magnet. Like you have seen that if you have two bar magnet, they are either attracted with each other or they will repel each other. If you bring the like poles, like North Pole to each other, then they will repel each other. If you bring the North and South Pole, then they will attract each other. So here also, if you have this North Pole and South Pole, and if this is normal wire, which is not having any current right now, so it is not behaving anything. But when the current flows through it, then the charges flow through it, and it start behaving like a magnet. So
And then I have a big, copper tube, which is connected to the wires here and there. When I connect these here, electricity will flow through this guy, through the red, through the copper tube, and then up through ground, and then back home. So we'll have electricity flowing this way, magnetic field pointing up. We expect a force inward. And sure
So you will
enough,
check that it is exerted,
we
a
get
force
an
is exerted
inward
here.
force.
Force is being exerted. Now
Now,
this, at
If
this
I
time,
reverse the direction of the current, we expect an outward force.
so you can check that it is
This guy over there.
then it is exerted, and means a force is being exerted. A magnet can exert a force on another magnet.
And there you see
If this
it.
copper rod is not behaving like a
Floating there.
magnet, then it will not exert any force.
Because now that
Copper
I've
can
reversed
exert
the
a force
direction,
on another magnet. Like I'm going to show you here. Bar magnet attracting each other, attraction and repulsion. So you can check it that when we bring the two bar magnet, they will either attract each other or repel each other. Okay, you can check it.
Is colored red.
Okay,
An attractive
now
force
these are
acts.
attracted, and when we have this, so they will repel each other. Sometimes they attract each other, sometimes they repel each other. When they have like poles, so how a magnet
Two
can exert a
identical
force,
poles. The South Pole
can
and the
exert a
South
force
Pole,
on another magnet.
or the
Okay,
North
a
Pole
magnet can
and the
exert a
North
force
Pole
on
repel each other.
another magnet. Got it? Okay, so this is the way that a magnet can exert a force on another magnet, and that is the reason that I'm going to. Okay, just a minute. So same thing that we were noticing here in this experiment, that when we are bringing a magnet, because these charged particles are behaving like a magnet, and a charged particle, and this prove that these are the charged particle beams, electron beams. Because if electron do not carry any charge, then it will not behave any magnet, and it will not be attracted or repelled by a magnet. If you bring a magnet nearer to it, then these are attracted or repelled. So let me show you that they are how they are attracted or repelled once more time. Then we shall be going to discuss further part of this one. So you can check it that
Next, we're going to look at the properties of electrons as particles and waves. This is called a cathode, and you're going to see a green beam.
so this is an electron
You can
beams.
prove that they're electrons by deflecting it with a magnet.
So these are deflected. Why they are deflected? Because these are the charged particle beam. And when she bring the magnet here, when she is going to bring the magnet here, then it simply means that these are charged particle beams. And since they are moving from negatively, like you see that
Which
when
we're
she
going
is
to
going
measure with this Geiger
bringing the magnet here, then it is deflected downward, not from here, from here. So it means it is
counter. I
started
can prove
from
that
here,
they're electrons
not
by
from here.
deflecting
Okay.
it with a magnet.
So it means that this is the negatively charged and they are moving from negative to positive. These are the cathode ray beams. Okay. Understood? Yes or no?
Yes,
Yes,
ma'am.
sir.
Yes, sir.
Okay, so this led to the discovery of this cathode ray experiment led to the discovery of electrons. Electrons are negatively charged, they move from negative terminals to positive terminals. Okay, they carry mass because they, when you keep the flying wheel, like if you keep a flying wheel in place of it, in path of this, then they will start rotating it. So it is only
Power
possible,
source.
like you can
The
see.
electrons strike the paddles, lighting them up and also making them spin. Let's see if
So this is only possible. This is only possible when we are having such type of means this is only possible when electrons are carrying mass, because when a mass particles hit another mass particle, then it transfer its momentum to it and it will let it to rotate. The flying wheel is only able to rotate when a mass particle is hitting the another mass particle. Okay, otherwise if electron do not carry mass, then they will not be able to have any momentum, because momentum is m into v. Momentum is P is equals to m into v. Then if mass is zero, then momentum is zero. Momentum is zero means no energy will be transferred. Okay. So simple manner, if I'm talking here that what are the experiments of cathode rays and how does, so draw this one please, and this cathode ray experiment, draw a rough of this one please fast. Draw it fast. Farhan, Irshad, Safia, and Sarah Beg, please turn on your camera. You done? Everyone noted?
Just 1 minute.
Yes, sir. 1 minute.
Sir, should we draw zinc sulfide?
Zinc sulfide is a screen that generally
No,
glitters.
sir, should we draw this?
Yes, you can draw this one.
Okay, sir.
They glitters when electron strike over it. So he puts the zinc sulfide screen here and note it fast. We don't have all day.
Sir, done.
Just 1 minute. We're done.
Okay. Write down the properties of cathode rays. Done? Note one more. Note it fast. Cathode rays moves from negative terminal to positive terminal. Cathode rays are electron beams. Cathode rays are negatively charged. Cathode rays led to the discovery of electrons. Done?
We're done.
Next. Then how actually the note one thing that cathode rays are independent on the nature of the material. Cathode rays are independent on nature of material of electrodes and also gas taken in the tube.
We're done.
Certain.
Okay. Now, the same experiment was done for the anode rays also. When he decreases further the temperature, further pressure in the tube. Okay. And he noticed that not only the electrons are coming from, positively, just let me explain you first, anode rays.
But does that mean that free of about all the we learned that? How do you think scientists would have found out?
Actually, when the electrons were discovered, the scientist was curious that they wants to uh, they want to discover the positively charge, because atom is electrically neutral. Atom cannot have only negative charge. If there is negative charge particle, then it must have some positive charge particle also. Okay, that's why, because atom is electrically neutral. Otherwise, if there is only negative charge particle in the atom, then we could get shocked when we touch something. But it does not happen in real life. So it means that there is some negatively charged particle is still present in the atom. Okay. So how does it happen?
Which was visible behind the cathode.
And he made this cathode ray experiment. Okay. Not only when he further decreases the pressure, this is an anode positively charged and this is a cathode. Now this time the gold iodine further decreases the pressure inside the tube. He further decreases the pressure inside the tube. Okay, and find that not only the electrons are coming from negative to positive, but from positive to negative they are also moving. And he made this time cathode as perforated cathode, which is having holes, so that electron can easily pass through. Okay, positive charge particle can easily pass through these holes in the cathode, and then he can measure here the things. Okay, just a minute.
He saw that these rays were passing through the holes in the cathode. He compared this to a rays passing through the canals, and that's why he called these rays as canal rays. And many scientists who named cathode rays because they were coming from the cathode, similarly, they named these rays as anode rays. So now that we have found these new type of rays, which are anode rays, we need to find out whether their properties are same or different from the cathode rays. So even though scientists had an idea that these rays are made of positively charged particles, they still had to verify that. So to verify that, they passed these rays through two charged plates and found that these rays were attracted towards the negatively charged plate. That clearly tells us that these rays are made of positively charged particles. Now, since these anode rays are probably made of particles, let's see what happened when they placed the paddle wheel in their path. As expected, the paddle wheel started spinning, suggesting that these anode rays are made of particles which have mass and velocity. So now, if you remember from the previous video, that when we brought a magnet close to the cathode rays, they were bent downward because they were negatively charged. So what do you think will happen when you bring a magnet close to these positively charged rays? Well, you are right. These rays will bend upward because the direction in which rays will deflect depends upon the nature of the charge. Now, if you notice carefully, you will see that the deflection in case of anode rays is way less than compared to the cathode rays. But why is that? Well, I want to remind you that
because the mass of because electrons get deflected easily, because the mass of electrons is less, so they can easily they get more deflected. Okay, and you know that, for example, if you have a small piece of if you throw a small piece of stone, then it will easily get deflected when some obstacle comes in its path. But if a heavy stone you are throwing, then it will not get deflected. So they are deflected, but not deflected as much as electron was deflected when we bring in a magnetic field or electric field in its way. Because proton, the positively charged particle that is called proton, is 1840 times. How much time? 1840 times heavier than the than the mass of electrons.
we learned in our ball and wind example
that the effect of a perpendicular force on a moving particle in a straight line is always less in case of heavier object than compared to the lighter object. So what does that tell us about anode rays? That tells us that even though we are using the magnet of the same strength in both the cases, the reflection in the case of anode rays is less because anode rays must be made of a particle which is heavier than the particles in the cathode rays. Now, to understand the nature of these charged particles, scientists changed the gas inside the tube and checked if the reflection would change. But they found something interesting. They found that the reflection changed every time they changed the gas. They saw that reflection in the case of heavier gas was less and deflection in the case of lighter gas was more. This clearly tells us that the particles coming from the heavier gas had more mass and the particles coming from the lighter gas had less mass. So now, can you guess what are these positively charged particles? Well, these are positively charged atoms. But shouldn't atom be neutral? Well, scientists realized when they applied a strong electrical force, electrons came out of the atom, and what was left behind was positively charged particles. These positively charged particles are nothing but ions created when electrons are removed from the atoms, which was seen as anode rays. After the discovery of the subatomic particles, scientists knew that atom is made of two entities, one which is positive, the other which is negative. But they wanted to know how are these particles arranged inside an atom? Does the answer lie in the structure of atom?
So now you understand the concept that
Yes, sir.
actually the electrons were deflected in case of hydrogen. And why do the anode rays? We write the previous statement that in case of cathode rays, these are independent on the nature of the gas. But actually, when we have in different gases, like for example, hydrogen gas. So hydrogen gas has, the nucleus of hydrogen gas is carrying one proton only. But in case of oxygen, it is having proton and neutron. The nucleus is heavier. So the reflection is less in case of oxygen because the nucleus of oxygen is heavy. But the electrons, since the electrons of each, whether it is whether the oxygen electron or the hydrogen electron, they are same. Okay, so in case of cathode rays, they are independent on the nature of the material and the gas taken in the tube. But in case of anode rays, they are dependent. Okay, they are dependent because the nucleus is different in different atoms. Like hydrogen gas nucleus is carrying only 2 mass, while the nucleus of oxygen gas carrying 32 mass. So the mass difference making it different deflections. Okay, understood?
Yes, sir.
Yes or no? So noted down the properties of anode rays.
Sir, what is the mass of proton after that?
Mass of proton is 1.67 in 10 to the power minus 27 kilogram.
No, sir, here, sir.
Mass of
After
proton
that.
is approximately equal to 840. This is the sign of approximate. Equal to sign and then with 840 times the mass of electron. And next one more point here that anode rays depends on the nature of the anode rays. Anode rays depends on the nature of electrode and gas taken in the tube and in the tube.
And then
Sarah, you done? Irshad, Farhan, why have you turned off
Yes,
your
sir.
camera? Are you writing?
Sir, done.
Yes, sir. You finished.
Okay, next. Next Thomson gives the plum pudding model for the atomic structure. Okay, and he gave this structure that is the plum pudding model. He said that now means because now electron and proton was discovered by cathode ray experiment or anode ray experiment by different scientists. So after the discovery of proton and electrons, it was necessary to give the structure that how proton and electrons are embedded. So what he said that atom is positively charged sphere and electrons are embedded inside it. Atom is, if we consider that atom is a sphere, as a whole sphere, and electrons are embedded inside it. Okay. So he find that atom is a positively, let's suppose this is a positively charged sphere. This is a positively charged sphere, which is carrying positive charge. And if we embedded electron inside it, embedded electron inside it, then these electrons, the total charge of these electron is equivalent to the total charge of this sphere. Okay, that's why atom is electrically neutral. So watermelon model was given by J.J. Thomson, and he gave that atom is positively charged spheres and electrons are embedded in it such that the total charge of electron is equal to total charge of positive sphere. Note it down fast.
Sir, should we draw the figure, both the drawings?
This single figure is same though. So why are you trying both?
Sir, sir.
Drawn. Done.
Yes, sir.
Yes, sir.
Next was cathode. After this one, there was a Rutherford model was done. Okay. So Rutherford actually was not sure for the with the experiment of this one, that or the structure that actually the Thomson gave. So he did an experiment. Rutherford. Okay. And he find that this is an Rutherford experiment.
स्कैटरिंग एक्सपेरिमेंट जे थॉमसन पहले सहमत किया। रदरफोर्ड ने इस एक्सपेरिमेंट को अल्फा रे स्कैटरिंग एक्सपेरिमेंट नाम दिया और इस एक्सपेरिमेंट की मदद से एटॉमिक स्ट्रक्चर को एक्सप्लेन किया। तो आइए इस एक्सपेरिमेंट को डिटेल में समझते हैं।
Actually, what he does, he took a gold foil and he take a circular zinc sulfide screen. This zinc sulfide screen is a specialized character that wherever the particles is going to hit, it will glitter there. So this glittering will tells you that where the particles are striking, alpha particles are striking. So he took a radioactive metals and passed it through these the specialty of this radioactive metal is that when these radioactive metals are passed, okay, they generate alpha particles. Alpha particle is helium nucleus only. If this is the nucleus of, okay, helium, then these are the two electrons. So when these both electrons are being loosened, then only the nucleus of helium is called He2 positive. It has 4 mass and 2 atomic number. Okay, and 2 electrons it has loosened, so it becomes the nucleus. The nucleus of helium is called alpha particles. Nucleus of helium is called alpha particles. And since you know that if we consider the whole Delhi as a size of atom, then the nucleus will be just a cricket ball. So it is very, very small as comparison to the size of an atom, the nucleus. So nucleus can easily pass through. The helium nucleus is also very small because it is the second element after the hydrogen. Okay. So the nucleus of helium is very small and it can pass easily through the gold atoms. The gold atom is here and this is the nucleus. So it can easily pass through it. So he tried to find out that what he find out, let me explain you here.
एनिमेशन में हम देखते हैं कि एक रेडियो एक्टिव सोर्स को लेड ब्लॉक यानी ग्लास कंटेनर में रखा गया है। इस रेडियो एक्टिव सोर्स से अल्फा पार्टिकल्स एमिट होते हैं। एक अल्फा पार्टिकल हीलियम न्यूक्लियस के बराबर होता है, जिसमें 2 प्रोटॉन्स और 2 न्यूट्रॉन्स होते हैं। इसका मतलब एक अल्फा पार्टिकल में 4 यूनिट मास और 2 यूनिट पॉजिटिव चार्ज होता है। रेडियो एक्टिव सोर्स के आगे एक थिन गोल्ड फॉयल को रखा गया है, जिसकी थिकनेस लगभग 210 नैनोमीटर है। इस गोल्ड फॉयल के चारों तरफ जिंक सल्फाइड की स्क्रीन लगाई गई है, जिसकी मदद से अल्फा पार्टिकल्स को डिटेक्ट किया जा सकता है। गोल्ड फॉयल और रेडियो एक्टिव सोर्स के बीच में एक ग्लास स्लिट को रखा गया है, जिसकी मदद से अल्फा रे को स्ट्रेट और नैरो प्रोजेक्ट किया जा सकता है। एनिमेशन में हम देखते हैं कि जब अल्फा रे को लेड ब्लॉक से प्रोजेक्ट किया जाता है, तब अल्फा रे स्लिट से पास होते हुए गोल्ड फॉयल पे फॉल करती है। अल्फा रे में जो अल्फा पार्टिकल्स हैं, वो गोल्ड फॉयल से स्कैटर होते हैं और डिफरेंट एंगल पे डिफ्लेक्ट होते हैं। ये अल्फा पार्टिकल्स जिंक सल्फाइड स्क्रीन पर एक ब्राइट फ्लैश लाइट प्रोड्यूस करते हैं, जिसकी मदद से अल्फा पार्टिकल को डिटेक्ट किया जा सकता है। आइए अब जानते हैं इस एक्सपेरिमेंट के ऑब्जर्वेशन के बारे में। ऑब्जर्वेशन ऑफ रदरफोर्ड्स अल्फा रे स्कैटरिंग एक्सपेरिमेंट। फर्स्ट ऑब्जर्वेशन, ज्यादातर अल्फा पार्टिकल बिना डिफ्लेक्शन के स्ट्रेट पास हो गए।
The first observation that most of the alpha particles goes in a straight line without any deflections. So it simply indicates that there is a lot of empty space in the atom, because if they are able to scatter, then okay. So this is the reason.
Most of the fast moving alpha particles passed straight through the gold foil. Second observation, कुछ अल्फा पार्टिकल्स बहुत स्मॉल एंगल पे डिफ्लेक्ट हुए।
This indicates that some of the alpha particles are deflected on a small angles. It means there is some charged particle present in the atoms through which alpha particle is deflected.
Some of the alpha particles were deflected by the foil by small angle. Third observation, लगभग हर 12,000 पार्टिकल में से एक पार्टिकल गोल्ड फॉयल से टकरा के 180 डिग्री पे बाउंस बैक हुआ। सरप्राइज।
So one of the alpha particle rebound back to its original path. This indicates that